Okay, good morning, good evening, good afternoon from wherever you are. So I'm Iman El-Dessouki. I'll be with you today instead of Udwak, the co-host, because she couldn't do it today, but it's my pleasure to be with you today. So I would like to welcome our audience, our speakers, to the third IEEE Women in Engineering UKI Ambassadors Program Early Career Talk. So I would like to invite Dr. Nagham Saeed to open this webinar talk.
Hi, and thank you, Iman. I'm Dr. Nagham Saeed, the IEEE WIE UK and Ireland Ambassadors Network Lead. I would like to welcome and thank everyone joining our Ambassadors' third event of the Early Career Talk program. This program aims to expose the audience to novel areas and aspects of engineering and computing, which solves real-world problems, and also to establish a link for networking and mentorship, and also to establish links with industry, and also to create connection for research opportunities. So a very warm welcome to our audience from all over the world. We had a look at the tickets, and we saw that we've got audience from Egypt and China and maybe more. So this workshop is a unique experience for our audience to witness talks from researchers who are not only from different universities, as you can see here in the flyers. We've got the speakers from University of West London, Northumbria, Ain Shams, Nottingham University, but also from different research engineering backgrounds. So you're going to listen to talks about water resource management, wave energy control, small cell technology, and robotic systems. Sorry. So that's research. We're going to have also talks which are research linked directly with industry. So that's something that we are proud to also present today in our talk. That's by Dr. Atiyeh, for example. You're going to see that all those talks are linked with industry, and maybe Dr. Tianyi Zeng is a very excellent example, because his talk he's a research fellow with Rolls-Royce, and his talk will be really linked directly with the industry. So a very warm and special welcome to our speakers today, and they all are in different stages of their professional career. We've got a senior lecturer, Dr. Yao, and we've got a lecturer, Dr. Atiyeh, a research fellow, Dr. Tianyi, and a PhD student in the middle of her PhD journey, Mayada. And so they all share the love for research, and that's why they are all here today to show their remarkable finding and their research outcome. So I'm really looking forward to listen to our speakers' talks and enjoy a fruitful discussion about their presentation. So back to you, Iman.
Thank you, Nagham. So now I'll start with you the agenda. So today, we started with the opening by myself and Nagham, and then we'll start the first presentation with Atiyeh. It will be 15 minutes, and then we'll have like 5 minutes questions for anybody. And then Yao will start her presentation for another 15 minutes, and then Mayada, and the last one will be Tianyi. And then we'll give like 10 minutes Q&A at the end of the sessions. There will be an evaluation form. If you can please just take like 5 minutes and fill this form for us. And then you can get after that, if you fill in your email, we can send you e-certificate. And then the closing remark will be by Dr. Nagham. I just want to mention some notes before starting. So the presentation recording will be broadcasted on IEEE section, region 8, YouTube. There will be one question for the audience after each presentation. So please provide your email in the evaluation form if you want to receive your e-certificate, which you can receive within like 4 days. Before we start, here are some housekeeping notes. You will notice that you are muted. You cannot share your camera. If you have any questions that occur to your mind during the talk and you don't want to lose track of, please do type them into the Q&A chat box and we can address those at the end. To target the question to the right speaker, the audience need to write with the question the speaker's name, or if you cannot remember, you can just write the order like 1, 2, the first talk, the second talk, 1, 2, 3, or 4, and we'll try to answer these questions at the end of the presentations. So now I'll hand over to the first speaker, Atiyeh, and then she can start her presentation. Please, we welcome you, Atiyeh, and I'll stop sharing and you can please share your screen.
So thank you again. It's a pleasure and honor to be among you all here. And so I will be talking about drinking water loss reductions in urban areas. My name is Atiyeh Ardakanian. I am a lecturer at the University of West London. A little bit about myself. I recently joined the University of West London, lecturing in civil engineering. But my own background is in civil engineering and urban planning. I completed my PhD at UCL, where I focused on socio-technical decision-making for urban wastewater reuse, focusing on arid and semi-arid regions in developing countries. I also did my master's at the Bartlett and UCL in urban planning and design, where I did my master's thesis on this topic that I will be talking to you about today and introducing it to you if you haven't heard about it before. I did my bachelor's again in civil engineering from Iran at Sharif University, and have been working with industry in Iran on water resource projects within the country. So with that, I will be going into the topic. So one of the major issues affecting water utilities in both developing and developed countries is the considerable difference that you see between the amount of water put into the distribution system and the amount of water that is billed to customers. And that is why it is called non-revenue water. High levels of non-revenue water reflect huge volumes of water being lost, and this is lost either through leaks within the system, so physical, technical leaks, or not being invoiced to customers. And I will delve a little bit more into what each one means and why it is important. So again, what is non-revenue water? It's the difference between the volume of water that you put into your distribution system and the water that is billed. It's defined into 3 categories: physical or real losses, commercial or apparent losses, and unbilled authorized consumption. What are our physical losses? They are leakage from any part in the system, overflows at utility storage tanks, and so on. And they are mainly caused by poor operation and maintenance, a lack of active leakage control, and poor quality of infrastructure assets. On the other hand, commercial losses are caused by customer meters that are under registration. They might not have proper metering. There might be some data handling errors by field workers, and in some cases, theft of water by illegal usages of water from where it is being distributed. Unbilled authorized consumption includes water used by the utility for operational purposes, like for firefighting and so on, and it is provided for free to certain consumer groups, or it is heavily subsidized. So in this table, you can see the whole definition and category of the water that we put in the system. So we have authorized consumption, which is mainly billed authorized and unbilled authorized consumptions, but our non-revenue water is mainly considering so unbilled meter consumption, data handling errors, as I mentioned to you, so the apparent losses and the real losses, which are the real leakages at the mains or the storage tanks, or even at the point of customer metering. Moving on, we do have a serious problem in regards to non-revenue water because it doesn't only financially affect viability of water utilities through their lost revenues and increase their operational costs, but it is a waste of resources. And this is especially significant in developing countries where there is not enough infrastructure for water supply. There are cases of water stress, water shortages. So this becomes more of an issue than maybe in other countries that do not have necessarily issues of water shortage. Now, the reasons for reducing levels of non-revenue water are compelling, and it is a widespread and generally well understood challenge. But I will unpack why it is not necessarily tackled and defeated. From a worldwide perspective, the total cost to water utilities caused by non-revenue water is conservatively estimated at 141 billion US dollars per year, and a third of this is occurring in the developing world. So in developing countries, about 45 million cubic meters are lost daily through water leakage in the distribution networks. And this is enough to serve nearly 200 million people. So that shows, the vast amount of waste that is occurring. Now, in addition to that, 30 million cubic meters are delivered every day to consumers. This is again in the developing countries, but this is not invoiced. So other than the 45 million cubic meters that are lost daily through the leakages, 30 million are delivered, but they are not invoiced because of corruption, poor metering, and so on. And all this directly affects the capacity of utilities in developing countries to become financially viable and fund necessary expansions of their services. This again specifically impacts the poor. So I brought that all in this table sourced from the World Bank. You can also see that it is not just necessarily a developing countries issue. You have this problem of leakages and non-revenue water in developed countries as well. As you can see in the table, the physical losses are less perhaps in developed countries than in developing countries. But still the total non-revenue water is significant in all of these countries worldwide. Now, reducing non-revenue water is not just a technical issue, it is also a social issue. And there are different things working behind this. First of all, civil engineers, historically, traditionally, we have always wanted to build large schemes, large dams, large treatment plants, and distribution networks, and things that are visible. So visible infrastructure, if you would like, rather than invisible infrastructure, which would be the pipelines that, rather than actually trying to manage and maintain issues with the invisible infrastructure that is usually underground. On the other hand, we have the politicians who enjoy opening ceremonies, ribbon cutting. Usually in developing countries, they are limited to their 4-year or a short term period while they are in power and would like schemes to be started and ended in their period of work, where they could boast about saying that this is what we've done during this time, and not necessarily responsibility and say that I'm sorry, there's been issues, with the distribution networks that already exist, and we need to put a lot of money and funding into that. You won't necessarily notice anything because it's all underground, but it would usually, for example, save resources and financial our financial capabilities as well. The other thing is, again, do the same political, economical constraints, operate under weak technical governance and financial framework. So again, opening this more in terms of the physical loss reductions, the politicians, there's no ribbon cut when you want to account for and manage and solve the issue with leakage. From the engineer's point of view, it's more fun to design treatment plants than to fix pipes buried under the ground. For technicians and field staff, detection is done primarily at night, and pipe repairs often require working in hazardous traffic conditions. So that's another obstacle. For managers, managers of water utilities mainly, it needs time. It needs dedication to have and upfront funding. So this is for the physical loss reductions. From the commercial loss reductions, again, from the politician's point of view, unpopular decisions might have to be made. So you might need to disconnect illegal consumers or customers who don't pay. This is not something that is very desirable. For meter readers, there might be some fraudulent practices that generate substantial additional income. So, that might be something that would prevent proper meter reading. For the field staff, working on detecting illegal connections or on suspending services for those who don't pay, again, is unpopular, can be dangerous. And for managers, it is easier to close any revenue gap by just spending less on assets, rehabilitation. So just letting the system slowly deteriorate and asking the government for more money instead. So the issue is there's too little support, and accounting all of this, except for the customers who do pay their bills, there seems that there is not really much support from any party to resolve this issue. Now, going back to the water utilities perspective, because they are the main point where they would be working on this issue and dealing with the customers. So they have to provide some form of service to customers on a daily basis. Their infrastructure is aging, deteriorating, and they lack the proper incentives, as well as specialist management and technical expertise to carry out the program. They lack the finance. So this is an area where the private sector in these countries can become of an assistance, and it could be ranging from long-term PPP arrangements to service contracts or contracting of certain tasks. Now, this again seems obvious living in a developed country, but in most developing countries, especially the water resources, they are heavily governed by a centralized government. So there is not that much room for private sectors to specifically enter within the realm of water resources. But there are certain, hybrids of, if you would like, decentralized and centralized systems where you can work with the private sector as a public institute and try to get finance from that sort of agreement and collaboration. What can the private sector bring? They can bring the new technology and the know-how to utilize efficiency. They can bring better incentives for better performance. They can bring creative solutions, more qualified human resources, obviously, and the flexibility for field work under different difficult conditions. So to wrap up, what the main thing I wanted to say was that there's a generally overlooked message in non-revenue water, and that it can't be considered in a vacuum. So you can't say there is just technical solutions, for example, acoustic loggers where you can detect the leakages and you can solve it. No, it needs to be studied within a broader context of a utility reform, if you would like. The designer of any non-revenue water program needs to look carefully at the incentives for the managers and staff of the program, as well as all the parties involved. And of course, there's a need to look at potentials for private sector involvement. And these are, again, recommendations that are usually made to countries from the developing region with water shortages that need to look into non-revenue water. I come from a country in Iran, which is in a semi-arid to arid region. There's huge issues with water, both losses and water shortage within the country. We have cities that are under severe water stress, but 40% of the water distributed to the water supply system in these cities is wasted through leakages. So it's a huge problem. It's a big problem. It's invisible, and going and trying to solve it requires taking into consideration a lot of factors that are not necessarily just technical. And with that, I would like to end my presentation. Thank you for your attention, for listening.
Thank you so much, Atiyeh, for this interesting and beneficial presentation. You discussed a very important topic, which is very critical. So thank you for all this information. I myself enjoyed it so much.
Thank you.
You're welcome. So I think we'll have the question at the end, because I don't have now questions in the Q&A box. So thank you again, Atiyeh. And I think we'll move now to the second presentation, which will be by Yao. So please, Yao, we welcome you to the stage.
Thank you, Iman. Let me just share my screen. Is it working properly, Iman?
Yes, I can see it. Yes.
All right. Thank you. Hi, everyone. Today, I would like to do a short presentation on the topic of prediction error tolerance control for the wave energy converters. And just a little bit background of myself. I'm Dr. Yao Zhang, and I'm currently a senior lecturer in the MCE department at Northern University, and I'm also serving a associate editor of IET GTD journal, and I'm also a local event coordinator of IEEE UK Airline section in the control system chapter. And my own research interests includes the control and optimization, machine learning based control, renewable energy system, and so on. So the outline for today's presentation are basically, firstly, I will introduce the WAC control problem. Basically, WAC is the wave energy control, so wave energy converter. And secondly, I will show you some simulation results on the prediction error degradation examples. And then the third part is the method that I've been using to cope with the prediction error, which is the model predictive control with inaccurate prediction. And then I'll give the conclusions. So the recent event of the COP26 mentioned that the wave energy has great potential to be delivering 20% of UK's current electricity needs. Currently, wave energy has not been widely commercialized. So for researchers, it's a good topic to do some investigation and research on it. Because compared with wind energy and solar energy, the wave energy is in a quite initial stage, and it needs more academic support, and also the industrial partners to do some work in order to boost this industry. So next question is why control is needed in the wave energy, because the current stages, wave energy has been done by like the tank testing or the real sea wave trial testing. And all that testing are based on different type of devices. And the most typical one is the point absorber. And in this stage, people in hydrodynamics are mainly using a passive damper as a controller, which just mirror the current velocity of the float and then give a constant gain to regulate the whole procedure. But if we consider that because based on the control strategy, we can see that it's not a optimal solution. And so what I do is incorporate more advanced control strategies. And what we do is we just optimize that signal put forward into the plant, and we do not need any extra sensors and any extra cost. So if you take a look at the figure here, we just firstly see the comparison between the red lines and the blue and the black lines. So you can see that if we use a more advanced control method, which is shown in the red lines, the energy output in the same time period is at least doubled by comparison by the people in hydrodynamics method. So this is quite convincing result. And the next question is why we need to consider the prediction error things, because the wave energy is basically a non-causal control problem, which means we need to focus on the future information of the wave in order to get the current optimal action. So when it comes to the prediction, it must contain some errors. And what we need to do is we must cope with all that errors that might happen in the real world. And we are aiming to solve it in software rather than doing it in a hardware way. Otherwise, it's gonna give you a high cost solution. So if we just compare the two red lines, so the solid lines means when we do the simulation, we use the 100% accurate wave, then the energy output is like is shown in the red solid line. But if we contain some prediction error, which means our prediction is not 100% accurate, which is more realistic, then you can see a slight degradation happens here. So the main topic today is how to cope with this prediction error. So we need to know what is the wave energy converter control problem. So in this figure, it shows a point absorber, which is like a benchmark problem in this whole community. So when you want to test whether your controller is working properly, you need to use this point absorber as an example, because it is easy to do comparison with other groups without, because everyone is using point absorber when we compare the performance. So the reference of this topic is basically these two papers, and the topics are on the MPC with inaccurate prediction. So before we move to the control part, we need to get some knowledge on the dynamic model. So you can see in the first line is basically the dynamic model. We just use the Newton's second law to deliver this. Is quite easy. And when we choose the output variable, state variable, and input variables, we'll be able to give this state space model here. So you can see this model now is a linear model as well as a LTI model, which means is time invariant model as well, because the whole structure of the model is not changed all the time. So only the input variable is changing. So basically, this is the property of the model. And now we take a look at the physical constraints and the control objective of the model. So when the wave energy is working, basically a float is floating on the sea. And what we can do is we use a power takeoff force in order to control the float. But when it comes to the point absorber, it's just one direction motion. So we have our own PTO limit because every device has its own limit. So basically, when it comes to control languages, like the input constraints happening. And when we consider the state constraint, it means the float. We do not want the float to be totally out of the water or just totally under the water. Otherwise, the whole electricity won't be continuous. So this is two state constraints and one input constraints. So the control objective is to optimize the equation here. And the first term is to maximize the energy. And the last two terms are to penalize state and input. So by using those whole structures, we develop our own control strategy. And the main motivation of doing this is, as I said, the back control is a non-control problem. So the prediction is essential and the prediction error is not negligible. And also the physical constraints should be considered as well. So by considering all those issues, we need to deliver the optimal signal subject to all these constraints and disturbances. And the contribution is quite clear, which is to cope with the prediction error explicitly. And also we need to ensure the recursive feasibility of the MPC. And also we need to keep the computational burden as low as possible because it's going to be a long-term running system on the sea. So we don't want the computer to be down or something like that. So that's all the requirements for the control. And how to ensure energy maximization subject to constraints and the prediction error. Basically, if we just define the prediction error as W tilde, so we can easily rewrite the state space model like this. And what we can know is the third term on the right-hand side of this equation is known, which is the predicted wave. So that one is known, but inaccurate. And the last term is unknown. So what the controller can use is the known but inaccurate term. And the controller is not aware of the unknown disturbances. So this gives the challenge to the whole system. And this is our main structure of the strategy. So basically we have a MPC and a capacitor working together to cope with the prediction error as well as giving the optimal signal. So if you take a look at the MPC on the in the yellow block, so you see the model predictive control is using the predicted wave rather than the real wave, because no one will know the real wave. We only know the predicted one. So MPC is using the predictive wave, and it's working on the nominal WAC model, which means the model without the last term. So everything here is now available, and the controller is just using any available information, and any information that is not available, we're gonna use it like a compensator, and we won't use it in the controller. So so this is the yellow block, and if you take a look at the green block, it is basically the compensator, and this one is to cope with the prediction error directly. So you see we can mirror some dynamics from the output. So it is feasible for us to let the whole system be aware of the prediction error. And when the system is aware of the prediction error, it is easy for the compensator to do the compensation itself. So everything happens automatically. And let's just see simulation results. So in the table 1, we are using all the parameters that everyone was using when we do the control performance check. So this is basically a typical point absorber WAC. And now we take a look at if there's no compensation. So you see the in this figure, you see the blue dashed line here. So if there's no compensation, but there is a prediction error, then the energy output is slightly less than the ideal one. And so it is like 14.2% of energy loss. But if we are using our own control strategy, which means now we are adding the compensation term in the control strategy, the energy output is barely affected. This is to be found by comparison between the red line and the green dashed line. So you can see there are only 0.3% of energy loss. So now we take a look at if all that constraints are satisfied. So first we check the input constraints. You see if so the black dashed line is the constraints of the input. So you see all the trajectories is always in the within this range. So the input constraint is satisfied. And with some rough waves, the input constraint is active. So this is to give a harsh situation to test the controller to see if when the C wave is quite rough, how the controller gonna perform, and the result is it working properly as well. So now we are checking if the constraints on the position and the velocity satisfied as well. So if you see the figure here, all the trajectory are always in the range that we preset it. So everything is working properly and the energy maximization is achieved. So to conclude the work, first of all, the prediction is rather important and could be estimated by advanced observers to reduce cost. And second, the MPC plus the capacitor can effectively guarantee optimal energy maximization when we do not have the accurate prediction. And the future research based on this work are going to be the deep learning based control, because when we do the wave prediction now, we are using like karma filter or autoregressive model to do the prediction. But what I'm thinking is we can use the deep learning method to predict the wave, and if there's any error happens, we use the capacitor to cope with it. And now it's pretty much everything for today's presentation. Thank you very much.
Thank you so much, Yao. This was interesting, and I think talking about controlling the wind and the diagrams you show, and even your idea and your future work is reasonable for everybody and is beneficial for everybody to know what's happening and what's going on and what's the future. So this was really nice. Thank you so much for that.
Thank you.
You're welcome. So, and I think we'll go like this. So we'll keep the questions at the end because I don't have questions now in the chat box as well. So now we'll welcome our third speaker, Mayada. So please, Yao, you can just stop sharing your screen, and we would like to invite Mayada to our stage. Welcome, Mayada, and we are looking forward to your presentation.
Thank you. Share screen.
Yes, please.
Okay. Hi, my name is Mayada Osama. I will talk today about interference mitigation and power minimization in 5G heterogeneous networks. First of all, my biography, I received a bachelor degree in 2012 and a master's degree in 2017, both from Mngmt University, Cairo, Egypt, in electronics and communication engineering. I am currently pursuing the PhD degree in electronics and communication engineering, also at Mngmt University. From 2012 to the present, I work as teaching assistant and assistant lecturer in the electronics and communication department at Masr International University, Cairo, Egypt. My research focuses on interference management, power minimization techniques for heterogeneous wireless networks. I will talk today, first of all, an introduction, then the challenges and opportunities, then the small cell on-off switching techniques, then about the soft frequency reuse concept, the objective of my research, the proposed soft frequency reuse-based subband allocation algorithm, and the proposed on-off switching algorithm, then the conclusion. First of all, the number of user equipments and wireless devices accessing the 5G network are increasing every day. The communication technology is expected to consume up to 51% of the global electricity by 2030. The small cell, or SC, is a new technology. It aims to provide 5G services to users. It can improve the coverage, especially in indoors and urban areas. It can actually be installed by the users themselves to enhance the coverage at home or indoors, or it can be installed by the mobile operators to enhance the coverage in urban areas. It can elevate the network throughput. Actually, two main challenges occur due to the dense deployment of these small cells. One of them is the large power consumption of these small cells. The numbers are increasing every day, so their power consumption is increasing, and there is huge interference between these small cells. Some of them are randomly deployed, so we don't have control over their places or their locations, so they can cause huge interference between each other without proper knowledge of their location. Two main solutions have been proposed to the power consumption and interference problems. One of them is switching the small cells to sleep mode. It's actually, if I have a small cell that is inactive at some point, I can switch it off. For example, if I have a small cell that is installed at a certain company, for example, and in the morning I have employees, at night I don't have any employees in the company. So we can switch off the small cell at night in order to decrease the power consumption and decrease the interference. The same if I have a small cell at home. In the morning, everyone is at work or school, so we can switch off the small cell in the morning at home. This is one solution. The other solution is the soft frequency reuse concept, or SFR, and we will talk about it later. First of all, the small cell on-off switching techniques, it's basically the ways to choose which small cells to be switched off. There are many techniques. One of them is the random on-off technique. It's basically like selecting randomly which cells to be switched off. The traffic on-off technique, it selects based on the traffic of the small cell. Okay, and the on-off switching according to the interference contribution rate values of the small cell. It actually selects which cells to be switched off according to something called interference contribution rate, and we will explain later what is interference contribution rate. The random on-off technique, where a certain percentage of chosen small cells are randomly selected to be switched off, while the rest of the small cells stay active. For example, in random 20% of the randomly chosen small cells are selected to be switched off while the rest stay active. It's basically randomly selecting which cells to be switched off, and of course it's not a good technique because we might select randomly a small cell having a large number of users, so we will lose a lot of traffic. The traffic on-off technique, where a certain percentage of small cells having the smallest traffic load are selected to be turned off while the rest of the small cells stay active. For example, in traffic 20% of the small cells having the smallest traffic load are selected to be turned off while the rest stay active. In this method, we mainly consider the traffic load of the small cells. We only consider the traffic load of the small cells. We don't consider any other aspects for selecting which cells to be switched off. The on-off switching according to the interference contribution rate or ICR values of the small cells. The ICR value of a small cell is the interference caused by the small cell to the sum of the reference signal received power, RSRP, of every active user in the small cell. It's basically a ratio between the interference caused by the small cell to the sum of RSRP of the user equipments in this cell. So it doesn't only consider the traffic in the small cell, it also considers the interference caused by the small cell. So if I have a cell having a small number of users, but actually causing a lot of interference to the neighboring small cells, I can switch off this cell. So the ICR concept helps to mitigate the interference between the small cell, and it minimizes the traffic losses also because ICR value of the small cell decreases when the number of user equipments in the small cell increases. So if I have a huge number of or large number of user equipments in a small cell, its ICR value will decrease. So it will less likely to be selected to be switched off. The soft frequency reuse concept. The soft frequency reuse concept in each cell is split into center zone and edge zone. Each small cell can utilize one of the subbands in its edge zone that are not utilized by the edge zone of the neighboring small cells. For example, I have here 4 regular shaped cells. I will divide the frequency band into 4 subbands, A, B, C, and D. Each cell will select one of the 4 subbands in its edge zone. For example, cell 1 will select A, cell 2 will select B, cell 3 will select C, and cell 4 will select D in its edge zone. And the center zone will be allowed to use the rest of the subbands with lower transmission power, minimizing the interference to the adjacent small cells and reducing the power consumption. So, for example, in cell 1, A is used in the edge zone, so B, C, and D can be used in the center zone. In cell 2, B is used in the edge zone, so A, C, and D can be used in the center zone. For cell 3, C is used in the edge zone, so A, B, and D can be used in the center zone. And cell 4, D is used in the edge zone, so A, B, and C can be used in the center zone. Of course, with lower transmission power, so minimizing the interference and reducing the system power consumption. The main objective is to present a new soft-frequency reuse-based scheme utilizing the interference contribution rate concept for small cell switching to mitigate the interference and to improve the power efficiency in 5G HetNets. Our proposed soft-frequency reuse-based subband allocation algorithm. First of all, we determine which subbands are used in the edge zone of the neighboring small cells. Then we don't want to use those, so we determine the remaining subbands for the edge zone of this small cell. And we want to use the subband which has the least interference. So we determine for each of the remaining subbands the distance between this small cell and the nearest small cell utilizing subband in its edge zone. We denote this minimum, and we find the subband with the greatest D minimum to be chosen to be allocated to the edge zone of this small cell. We basically try to find, we try to eliminate all the subbands used in the edge zone of the neighboring small cells. Then for each of the remaining subbands, we try to find which one is used the fastest, which one has the least interference to be selected for usage for the edge zone of this small cell. The proposed on-off switching algorithm. First of all, the small cell is classified into one of 3 cases, either off, on, or undetermined. Off, if the number of user equipments in the small cell equals 0. If I don't have any user equipments in this small cell, I will switch it off. Okay, so the small cell is then added to the set of small cells that should be switched off on in one of two cases. If the load of the small cell exceeds a certain threshold, the load of the small cell is the total number of required resource blocked by the user equipments in the small cell, or if the maximum RSRP of the small cell exceeds a certain threshold. In both cases, I will switch the small cell on, and the small cell is then added to the set of small cells that should be switched on. If neither of these cases occur, we will add the small cell to the set of undetermined small cells, which will then be classified into one of two cases, either off or on. We will calculate the interference contribution rate value of the small cell. Like we said before, it's the ratio between the interference caused by the small cell to the sum of RSRP of the user equipment in the small cell. And we will calculate the average of the ICR values of the small cells in the set of small cells to be switched on. If the interference contribution rate value of this small cell exceeds the average of the ICR values of the small cells, the cell causes huge interference and should be switched off. On the other hand, if the ICR value of the small cell is below the average of the ICR values of the small cell, then I can switch on this small cell. As the conclusion, the soft frequency reuse concept with the small cell on-off switching approach is addressed, and it's a promising approach for interference mitigation and power minimization for 5G headnets. Various soft frequency reuse switching on-off techniques have been demonstrated, such as proposed, random, and the traffic. The proposed scheme is able to reduce the interference level and minimize the power consumption and diminish the traffic losses in 5G headnets. Thank you.
Thank you, Mayada, for this nice presentation. So I think when it comes to 5G and communication, everyone wants to listen, even if they don't have a telecommunication background. So because it's all around us, so everyone is interested to hear more about its problem, the interference problem, anything like that. So, and also I think the power consumption is a global target, so it's not related to any country. So each countries just are targeting to the power consumption. So I think this was very nice presentation. Thank you so much for that.
Thank you.
Thank you. So, and now, so kindly just stop sharing your screen. Thank you so much. And then we'll invite our fourth and last presenter. So kindly, Tianyi, if you can just share your screen. Thank you so much. So we are looking forward for your presentation.
Yeah, thank you.
Thank you. Yes, perfect. Thank you so much.
Yeah, thank you. Hello, everyone. I'm Dr. Tianyi Zeng from Rolls-Royce University Technology Center at University of Nottingham. And it's my great honor to present my research. And first of all, I should say thank you to the organizer and other staff running this event. And here is a little about myself. I have got my PhD degree in control science and engineering from Beijing Institute of Technology in 2020. And after that, I became a research fellow in robotic control in Rolls-Royce UTC in manufacturing and on-wing technology and at University of Nottingham. And in our UTC, we have several research groups exploring all aspects of aerospace manufacture with particular interest in the area of fixture and on-wing inspection and repair based on robotic systems. So generally, we have 3 research teams. The first one is advanced manufacturing, and the second one is innovative fixture and touring. And finally is the team which I belongs to is robotics for the on-wing service. So today, first result I want to share with you is the plant and controller co-design. So by talking co-design, we should know that the conventional system design procedure. In the conventional system design, the plant and the controller always say that mechanical structure, they are designed separately. So the controller is developed with fixed plant parameters. And if the system performance is failed to match the requirements of the control performance, we need to go back to the plant design again. And then with another group of plant parameters, we need to design the controller again. And then the whole design procedure is an iterative process, which means that we need to design the plant and its controller, and then repeat the whole procedure. So if we want to achieve the overall system optimality, we can't use the conventional design procedure, because actually we are trying to design the plant and the controller separately, which means that we are developing the subsystems. So if we want to achieve the overall system optimality, we need a performance index which can optimize the plant and the controller simultaneously. And this is the co-design performance index. So in the co-design scheme, the first challenge is that even if the performance index of the plant and its controller are convex respectively, the combination of the plant and the controller can lead to an unconvex optimization problem, as shown in figure 2. So we employed a nested optimization method in our co-design scheme with 2 nested optimization loop. The outer loop is for the plant optimization and the inner loop for the controller optimization. So in that way, we can optimize the plant and the controller simultaneously. And so that we can achieve the overall system optimality. And to verify the effectiveness of the co-design method, we introduce a motor servo system with a driving motor, gearbox, and the load to be driven. And I choose the load as the plant parameters to be optimized, and guarantee cost controller as the control strategy. So actually, I'm seeking largest load, which can be driven by the servo system with a satisfactory control performance. And here is the tracking performance and the tracking error. We can see that by using the control strategy, we can achieve a satisfactory control performance. And here is specifically result for the co-design. And by different weight parameters, we can achieve a Pareto surface of the load for the system. And we can also achieve the control input corresponding to different load. So here we can see a trade-off between the control input and the load we can drive it, which means that if we want to drive a larger load, we need a larger control input. So this by this result, we achieve another benefits of the co-design, which means that by designing the whole system, we can see if there is a limitation of the control input, we can only drive a smaller load. And if we want to drive a larger load, we need a larger control input, which means that we need a better driving motor. So this is the co-design result, and basically by using the co-design scheme, we want to optimize the structure and its controller parameters simultaneously. And the requirement is actually from our industrial partner for a radar system. And we have achieved some results with several publications. And I think the co-design method is flexible to other ongoing research or project which needs the robustness or reliability improvements or system optimization. And this kind of control strategy can make the contributions quite straightforwardly. And I think we have some potential collaborations. And actually, we have already applied the co-design scheme to some renewable energy system. And we have also introduced other kind of controllers into our co-design scheme. And currently, I'm working on the co-design method that we can use it on the robotic system for the on-wing service. And unfortunately, I haven't got the clearance from Rolls-Royce to present our latest results. However, I'm allowed to share other results from my group, and they are also for the on-wing service. And by the on-wing service, we need the on-wing technology, which we can detect and repair the aero engine while they are installed of the aircraft. So the first benefits of the on-wing technology is that we can significantly reduce the disassembly or assembly cost and non-operational time for the aero engine. And obviously, we can reduce the scrap rates, increase the overall profitability. And it is a little bit fancy or popular recently that we can reduce the carbon dioxide emissions by avoiding the disassemble and assemble procedure. So this is the first result from my group. It is a continual robot for the on-wing service. And basically, my team have developed a snake arm robot, which we can insert it into the aero engine. And this video is a whole procedure from the very beginning. So you can now see that we are trying to set up the whole system. So now you can see that we have already inserted the snake arm into the aero engine. And we can control the snake arm remotely. And here is another result from my team. And the previous video that we have developed a single snake arm that we can insert it into the arrow engine and do the service. And in this result, we have made the collaboration of 2 snake arms. Yeah, thank you for watching the results from my group. If you have interest, you can contact Professor Drago Saxington, who are our director from the UTC. And if you have interest in our research and have some ideas about the collaborations with our team, you are very welcome to follow our website and social media. So yeah, thank you all. And that's pretty much for my presentation. Yeah, thank you.
So thank you so much. It was really nice. So, and the idea of just presenting with videos, it gives the simplicity and how everyone can just get the idea without the technical complications. However, it's very complex, I can understand, but it's the easiest way just to show your ideas. So I found amazing the video of the two snake arms. So even the part of the target identification and management, and even the repair quality verification, this was really amazing. So it's very nice. Thank you so much. So we have for you a question in the chat box. So I'll share it with you. I don't know if you can see it. So it's by Reza. My question to the last speaker, can you read it?
Yeah, let me just.
Do you optimize the simulated scenarios? If yes, what is difference between simulated optimization and optimized simulation related to the results in your case?
I think it's a question about the co-design method. So basically, in the simulation, we do the optimization so that we can know the specific structure parameters and the controller parameters. And with that kind of optimized parameters, we can develop the real mechanical system and apply our controller directly to the mechanical system so that we can achieve the satisfied control performance. So what we have done with the co-design scheme, that we are trying to avoid the iterative design procedure. Basically in the conventional design procedure, we need to develop the mechanical structure, and then with only the fixed mechanical design, we are trying to develop the controllers. Hope that answer your question.
Yes, thank you so much.
Yes, he's saying thank you. Yeah.
Yeah, thank you.
I've got also a question for you, Dr. Tianyi. Of course, I really enjoyed your presentation. It was really enjoyable. And I would like to talk about the two parts that, and ask about the two parts that you presented in your presentation. The first part you did, you did a great job with controlling input parameters, and you show like experimental work in the lab. And of course, some publication. So are you thinking of going to the next stage, which is the implementation, just propose this to real world and seeing the effect of your design?
Yes, currently we are trying to extend the application of the co-design into the robotic system.
Mm-hmm.
And this kind of robotic system is used for the on-wing service.
Mm-hmm.
And yeah, in the robotic system, we have several structure design, because we need to develop several different end effector to use to provide the on-wing service. So there are many structure parameters and working with the controller. So yes, we have already extended to the robotics control.
I can see it's been applied to motors in this case.
Yeah.
So where do you think are the best, or the market for your design, if we can say so, where they can be really effective?
Yeah, I think it can make the contributions in the design procedure so that we can make the whole procedure more efficiency and save our times, and to avoid the waste of the materials, because if you want to change the mechanical design, it is very difficult. Maybe you need to manufacture the whole system from the very beginning.
Yes, yes, definitely. On the second part of your presentation, the on-wing and the results that you achieved and the video you showed, it's really very promising. But that's all wired, isn't it? Not wireless.
Sorry?
I mean, I saw that your system is connected in a wired way
Yeah.
with wires to the,
Yes, yes.
to the section.
Yeah.
Do you think this is one of the limitations for your design?
Yeah, actually, we designed it based on the wire because of some requirements from Rolls-Royce. They need to hold the snake arm. So that's why we choose the cable-driven snake arm. Otherwise, there are some other results based on some the air-driven of robotics.
Okay.
So we need to insert it into the aero engine and do some inspections and repairs. So that's why we choose the cable-driven snake arm. Yeah.
Yeah, so I saw inspection, I saw repair. Is there any other functions that you would like to add to the, or you are thinking of for future work?
Yeah, one of my current projects, we are working on the welding repair for the aero engine. So yeah, basically we develop a controller for industrial robot, and we let the industrial robot hold a very small but long end effector, insert it into the aero engine and do the welding task.
Do you think this design also can be useful if we apply it to water grid or oil pipe grid? And that's why I asked you why it's Are you thinking
actually,
of wireless? Because you know those the detection process, it really needs like flexibility.
Yes, yes, indeed. Actually, we have do the experiment in the pipe. So with a very small camera to see the situation inside the pipe. Yeah.
But those are for short distance, not for long distance, isn't it?
Yes, yes. There, it's a limitation of the snake arm. You know, you can't. Actually, we have two snake arm. One is 5 meters that you can see in the video, and we have the longest arm is 15 meters.
Nice.
That's the longest one we have.
A very interesting result. Thank you very much.
Thank you.
So
any questions?
So there was a question for Atiyeh. It was in the chat box as well.
Yes.
Yes.
The question is, hi. Yes, it was. What is the most effective way of taking attention to drinking water loss reductions?
Yes.
Or revenue water. And it's a good question because there are actually ways. One of, I think, the most important one would be media. So if the media would be able to bring more attention to the wider public about this issue, then in turn they would be expecting it from, you know, their council members, politicians, or water utility managers to account for this. And the other way would be to encourage or pressurize water utilities themselves, talking in the absence of, you know, any private sector involvement, whereas in places where there's a lot of leakage and a lot of loss, the water utilities would have to decrease the rate in which they bill their consumers. And so that would be sort of a reverse incentive for them to try to resolve that issue, or you know, encouragements to them for actually trying to reduce the leakages themselves by the government or whatever funding body they are getting their finance from. I think these two would have a good impact on how this issue is addressed. Yes, thank you.
Thank you so much.
I've got a question for you, Atiyeh.
Yeah, sure. Go on, please.
Thank you very much. I wanted to ask, because you were mentioning many parameters which in your interesting speech about areas, those parameters were not looked at, which is, for example, unbilled issues. So which one you think is the one with the most potential and also ignored? No one looked at it as a loss. I wonder if my question is clear.
Oh, that's a very interesting question. So you're asking that within all of the different losses that exist, which loss do I think is overlooked?
Yes.
I think the losses from the metering, talking about developing countries, from the metering side is the overlooked one, because bursts in pipes or leakages in pipes are known to most of the utilities that are working on that. And there are things that they do to try to overcome that. For example, they send the water in with higher pressure. Whereas at the end, it increases the losses because you're sending a higher pressure to an end point where it doesn't necessarily need that pressure. So you're wasting water in that sense. But I think metering is overlooked in a lot of developing cities within developing countries. Many household units share the same meter. And there's not that much work done on trying to differentiate these together. Again, another loss that is more on the consumer side is, so I'm thinking about Iran when I'm telling you about this. We, and during the summer, we use a lot of coolers which work with water. So they're very basic air conditioning. And they use a very, very limited continuous flow of water in them, which can't be picked up by normal meters.
Yes.
So you have this water going on, it's not being billed, and it's being wasted in terms of finance. So I think that would be my take on.
That's really good to know. And my last question before I let the others ask is, this is all about the water pipe or the water system, how much we can take this to apply it to the oil grid systems. From, I mean, the concept, your concept, how much we can apply from all what your study or your research, because both of them, they share kind of the same similar ideas for the distribution system, the problems with the leakage. So how much from your research we could relate to oil pipe grid systems?
Again, that's a very interesting perspective. I think the common issue would be the human resources in this case, because the technical issues are relatively well known. There are solutions for it. Obviously, there are newer technologies. As you know, in our university, we are working on it, like using AI for this matter. But I think it's more on the trying to deal with the managerial aspects of understanding the economic and the political context of where we're working in. What are the regulations? How do they finance their projects? Who owns what? And that, if we're able to map that out and try to understand what each of, if you would like to call them stakeholders in this little system boundary of ours, what are their priorities? What are they looking at? How we can incentivize them? We can, have a group working towards an issue rather than just trying to fix little points within the system, and again, not really having much of an impact. I think that is something, and again, providing more knowledge about this, sharing more knowledge about what is happening. I think it's similar as the case that you mentioned. This is not really well known or well looked at because it's all invisible infrastructure. So I think if more research is done in this regard, it's more publicized, it could gear towards more impact.
Thank you. Thank you very much.
Thank you.
Iman.
Yeah, so I'll ask you a question, please, Atiyeh. So what happens to the leaked water from the water pipes?
Oh yes, the leaked water. So Contrary to what we may think that it would, go back into the environment and into the cycle, that doesn't necessarily happen. Depending on where the leakage is happening, that water might infiltrate a bit, but it wouldn't necessarily recharge groundwater tables. So it would be wasted within the built environment, or add a burden to the already maybe filled combined sewers that exist. So that is also another point that needs to be looked at, which would emphasize the importance of trying to fix this issue.
Okay, thank you so much. So I think Nagham, you raised your hand. So do you have a question or something?
That's for Atiyeh, sorry, no, that's for Yao.
Yeah, sure. Thank you so much, Atiyeh. Okay, you can say your question, Nagham, to Yao, please.
So Yao, thank you very much for your presentation. And you mentioned a very important point, which is the wave control or wave harvesting. It just really wave energy harvesting. It's an area which is really not looked at. And you are right. We talk more about PV, we talk more about wind turbines, but we don't talk about waves at all. Of course, I believe there are some limitation if your country we don't have like sea, or there is also barrier, but why we can just my question is how we can promote this wave harvesting, energy harvesting, and if we would like to compare them to the other ones, why this one gets potential, why we should go with wave energy harvesting.
Yeah, thanks, Zeng. It's a really good question. So basically, the reason why wave energy has not been widely commercialized is based on the limitation of the limitation on the device. So if you think about the wind energy, so everybody know that we are not harnessing the wind energy by using the wind turbine. And the shape of the wind turbine, as well as all the structural parameters, are quite mature, like quite fixed. So everyone was using the same device. And but for wave energy, we haven't invited the best device so far. So that's basically bring the main limitation of commercialization on the wave energy, because different companies use different type of devices. And when it comes to the commercialization, people will get confused, because there's no every company is saying their own advantages of designing the devices. But the thing is, for the whole wave energy industry, we need a most efficient device. And for the control part, we are just doing the optimization based on a fixed device. So if the device has not been optimized, then control, which is the next step of this, cannot be moved forwardly. So that's the basic reason for if we just compare the wind energy and the wave energy. But the good thing is UK is taking the lead in the wave energy research, also the industry, because we got some 2 or 3 big company on the wave energy in Scotland. But in England, most of the company doing wave energy are the SME. So it's like small size or medium size. So the impact is not that significant. So all those factors bring challenges. But for me, I think it's good for me to do research, because there's, not many people are looking at this area, and I can do some original work. So yeah, so that's the
yes. And actually you answered my second question, which was what's the limitation in the current model for harvesting energy from the wave. And the thing is, I mean, this is also something I would like to add. Just many times I see like wind farms in the sea, but I don't know why there is no a model which can adopt both energy, wind turbine, and also wave energy harvesting at the same time, because they are in the same position. Yeah.
Yeah, that can really, it's really good question, because I know that there are some research group trying to combine the wave energy and wind energy, because the wind energy is offshore as well. So they're trying to combine those two energy resources in one system. But the thing is, the whole system becomes quite stochastic, because the wind itself is quite stochastic enough. But if you want to incorporate the wave, as I said, the wind energy is not a non-causal control problem, which means the wind, we do not need the future information on the wind, but we do need the future information on the wave. So it's definitely increased the complexity of the whole system. And the benefit of doing that is not quite clear. So people don't want to take that risk. But from the perspective of research, there are some research on like combining those two systems, but everything was on the theoretical level. Yeah, it's like if you want to do research, it's good. Yeah.
Could you elaborate more on the limitation for the current system? Because I saw in one of your slides there were like cables which are taking the harvesting the energy.
Yeah.
So is there any other ones which you can mention?
Yeah, and it just come to my mind is the wave to wire structure. So when you finish harnessing the energy and you need to convert it to the electricity. So during this stage, the energy conversion rate is not that high for the wave energy. So this is also why I said there's no clear benefit of incorporating wave energy to the wind energy system.
Yeah.
So and also for the wind, if you want to select the location to put the wind turbine, basically people doing wind farm in order to select the good location. But if you want to incorporate wave in this area, you must consider the best location of putting a VAC as well.
Yeah, it could
and those two might be conflict with each other. And again, the wave incorporating the wave energy is not clearly stated like it's quite beneficial to do that. And it means if we want to incorporate wave energy in that system, it means that we need to upgrade the whole system. So I don't think people will like that.
Yeah.
But at least in current stage.
Yeah.
Yeah.
One of your slides, why control is needed in wave energy, I saw like one of the control methods that you've been using, bank, case one, and then case two. There was a big difference between the result that you achieved with bank case one and the one that you achieved with the case two. So can you elaborate on this?
Yeah, so I can share that again. So
yes, please.
That's my last question, Iman. That will
Yeah, that's all right.
Thank you for being interested in this research. So Nagham, I think you're talking about this figure.
Yes, I'm talking about this figure.
Yes,
yeah, so the right line is made by my own control strategy. And I mentioned that the blue line and the black line are basically the simulation result from people in hydrodynamics. So they treat control as a passive damper, like they just want the control to stabilize the whole system. They do not aim at maximize the energy. So that's why I think this is something that I can do, because I think control is not just to make things stable, but to make the whole system optimal.
Mm-hmm.
So
yes.
I incorporate optimization as well as like the model predictive control. There are many optimization ways that we can do it. And what I show today is the model predictive control. So you see the red line here, and it's very interesting result, because as I said, we do not change anything, any parameter from the device. We use the same device, the same wave. We just optimize the signal that fit into the plant. So the signal is from the calculation of the equation. So the hydrodynamics people use this. Use this passive damper, and myself use this structure. Because it's a little bit complicated. It cannot be just written as a equation, but what I mean is I'm just optimizing the signal, and by giving the different signal, we have such different energy output here. So that's the novelty and the motivation of doing this.
I can see also other techniques that you compared your methods with are not doing as good as yours. So well done for this. Thank you very much. Thanks a lot.
Thank you.
So thank you, Yao, so much for all this elaboration. So I have a question for Mayada, please. So
yes.
So I want to ask you about why did you choose the on and off switching technique based on the ICR concept and not the traffic on and off switching technique?
Yes, because the ICR concept actually doesn't only consider the traffic of the small cell, it also considers the interference caused by the small cell, which is a really important topic, because if I have a small cell that causes a lot of interference to the neighboring small cells, and it's only serving a small amount of users, so switching it off might be a good idea to, and actually handing over those users to either the macro cell or the neighboring small cells if it is available. So it actually doesn't only consider the traffic, it also considers the interference caused by this small cell to neighboring small cells.
Okay, interesting. So I think, Nagham, you are raising your hands. You have a question?
Yes, I am. And I would like to say thank you for Mayada for her interesting talk. And would like to ask her about the decision making, because you were saying that the nodes, they're going to be switched on and switched off. So which one do you think will take the responsibility of making the decision making? Which one should be on and which one should be off?
We have a main controller. It's a utility that takes the decision of which cells is on or off, and it actually can take the decision to hand over the users to the macro cells if I switch off a cell that has a small number of users. So in order not to lose the traffic in this cell, we can hand over the other the users in this cell to the macro cell.
So where this controller will be? Where this controller?
Mainly, it can be mainly in the macro cell. We're talking about this space.
So you should also look at the ability of these microcells, if they will be able to handle all this processing which going to happen.
Yes,
isn't it? So it's according to ability.
Yes, we measured also traffic losses if the macro cell doesn't have the ability and it was in the minimum acceptable ratios for the traffic losses. If the macro cell doesn't have the ability, if it's full or it doesn't have the ability to carry the traffic.
Yes, and another point here, some of the small cells that you will not provide this, decide to switch them off, and I think you mentioned now you've got like channel 20 and you've got 20 users, so only 20 and the others, they will not get service. Is that going to affect the quality of service in your opinion?
No, it's 20. It means that 20% of the cells are selected to be switched off. It's in the random or the traffic. When we compare our work with the most common techniques used now, so the random 20 is like selecting 20% of the cells, randomly selecting them to be switched off. So of course there will be traffic losses in these cases, and actually the random technique has the highest traffic losses because it doesn't consider any aspects. It's only randomly selection. So sometimes it selects small cells with high traffic. So the traffic losses are huge.
So definitely your technique, in spite of not being able of serving 20% of the customers, but it is the quality of service percentage is higher than the random technique.
Yes, it's not. Yes, it's not. In my technique, it's not a percentage to be switched off. It actually I can. I want to share the results. If I have this paper. I can share. Here is the amount of traffic losses for my technique. It's the red one, okay, compared to the traffic and the random. Random 20 is randomly selection of, it's randomly selecting 20% of the cells to be switched off. 40 is randomly selecting 40%, 30 random selection of 30, and traffic 20 is selecting the 20% of the cells having the smallest traffic load to be switched off. Same for 30 and 40. So my technique has the least traffic losses compared to the traffic and the random. Of course, the traffic losses in the traffic technique is less than the random because it considered the traffic, and the random has the highest traffic losses. And also, I want to share something if I have. Here is the number of switched off small cells in the traffic or in the random. It's a percentage, so it's a constant number. It's percentage of the small cells. In my technique, it's not a percentage. It's it actually depends on the value, ICR value calculated. So if I have small number of users, for example, I have a lot of cells that I can switch off because they don't have users, or they can be handed over to other cells, while when we have a large number of cells, like the case when we have a large number of users, like 900, we have a small amount of small cells then can be switched off, so we don't have large traffic losses.
Yeah, thank you, and thank you for sharing also results, because that's really add to your presentation. So thank you very much, and good luck with your publication.
Thank you so much, Mayada, and thank you so much, Nagham. So now I'll just put in the chat a link for anybody who can just share in the evaluation. And I'll give, because I think we finished the time, so Nagham has only 1 minute to wrap up all the event and to thank everybody. So the mic is yours now, Nagham.
Thank you very much, Iman. Thank you for standing instead of work for this presentation. Thank you for your time. And I would like to thank the speakers and our audience. We are very privileged to listen to these interesting speeches today. It's clearly shown today how our researchers, they showed their unique outcome in their research and the different tools they've been using to reach these outcomes. Really, we are here in this early career talk, we are having very important features, making sure that we have international representation even from outside UK, and point out the work that's done by women in engineering outside UK, and that's presented in this event by hosting PhD students Mayada, Osama from Egypt. And also another important feature for the event, which we are proudly capturing today, is making sure we are addressing diversity and hosting a male engineer. So this is for the first time we are hosting in our program Dr. Tianyi Zeng, and we are privileged to listen to his presentation. And I promise you, this is not the last time we are having a male presentation in our programs. And again, the last thing I would like to say, not the last, maybe before the last, is we are calling for women in engineering and computing to give technical inspiration and empowering sessions. And that will be just this program, for example, early career talk support programs for women from academia and industry who've got less than 10 years in their field. So please watch out for our next event, our early career talk, which is going to be in February 2022, and the call will be sent soon. And the last thing that I would like to mention to our speakers and our guests today is Merry Christmas for the people who are celebrating this jolly month, and the ones who don't, a very happy holiday season. And thank you from me. Back to you, Iman.
Thank you so much. Thank you for the speakers, and thank you for anybody who attended today. So, and see you in the coming event. So next year in 2022, see you with other workshops and new events and new series. Okay, thank you. Bye.
Bye.